Welcome everybody, this is section 5.4.2, the remainder and factor theorems. As promised, today we're going to talk about the factor theorem. So the central question for today is what happens if the remainder is 0? And so I guess what we should really do is practice one of the skills that we had from last class, that's rewriting division as multiplication. We all know that 30 divided by 5 is 6 with no remainder, but if you rewrite it as multiplication, it's 30 equals 5 times 6. And then 50 divided by 10 is 5, remainder 0. That's 50 is equal to 10 times 5. That's to talk about it in a real concrete way. But if you're looking at polynomials, what that would mean is x squared plus x minus 2 divided by x minus 1 is equal to x plus 2, remainder 0. You can also rewrite that and say that x squared plus x minus 2 is equal to x minus 1 times x plus 2. Well, if the remainder is 0, then the divisor is a factor. This divisor of 5 is actually a factor of 30. The divisor 10 is actually a factor of 50. And the divisor x minus 1 is a factor of x squared plus x minus 2. If the remainder is 0, the divisor is a factor. So the big idea is going to, So the big idea when you translate this into polynomials is that you should first divide p of x by x minus a. And if the remainder is 0, then you found a factor. X minus a is that factor of p of x. And that's the factor theorem. Finding factors is from like giant polynomials or giant numbers is actually a huge deal to internet security. In fact, it's the only thing. The fact that this is difficult is the only thing that keeps all banking records everywhere on the entire internet safe, or any kind of privacy, or anytime you enter in a passcode, you are relying on the fact that this is actually difficult. And if you want to know how more, then stop me for a hot second during lunch or when you finish the assignment, and we'll talk about it because it's actually fascinating. Here's what this would look like on alex.com. It might say something like this: use the factor theorem to determine whether. Let me zoom out just a little bit. Why can't I zoom? Use the factor theorem to determine whether x minus 1 is a factor of this giant polynomial. Specifically, evaluate p at the proper value and determine whether x minus 1 is a factor. What they're basically just trying to say is divide. Take this and divide, and if you get a remainder of 0, if the remainder of 0, then yeah, it is a factor. So this is basically a yes or no question, and they are asking you to do it in a specific way. So let's take x minus 1, translating this divisor into synthetic division. Yeah, use synthetic division. It's gonna be super fast to do it that way. So 2 down to 2, bring down the 2, multiply by 1, you get 2. Add negative 1, you get 1. Multiply by 1, you get 1. Add 0, you get 1. Multiply by 1, you get 1. Add 3, you get 4. Multiply by 1, you get 4. Add negative 4, you get 0. Aha! The remainder is 0, and so therefore the answer to this yes or no question is yes. X minus 1 is a factor. There was no remainder. If you get something else aside from 0, then the answer is no. That's what it might look like on alex.com. So this is important because we often solve equations by factoring. We did a ton of this in chapter 3. When the exponent was no higher than 2, it was our study in quadratics. We did all these different techniques. We did split the middle. We did complete the square. We did the quadratic formula. We did all of chapter 3 in trying to figure out how to factor equations so that we could solve them. That's one of the biggest reasons why we would factor, is because we want to solve equations. Now, you might wonder, hey Berg, is there like a quadratic formula for when the exponent is 3? And the answer is yes. You should Google it if you want, but it's huge. It is massive. I don't think anyone has actually ever come up with a song to express to remember that. It's just way too complex. So what we're really going to do is guess and check. It's actually going to be the fastest way, especially if alex.com is kind to us, or the SATs are kind to us. Usually it's not going to be, you don't have to guess and check like the numbers like negative 1.6. It'll be the answer of like 1 or 2 or something. So we're going to guess and check, and we're going to use the factor theorem. So this is what it would look like. So you might have a polynomial like 2x cubed minus 5x squared minus 23x minus 10, and you're wondering whether or not x minus 1 is a factor. Well, just use synthetic division. You do the synthetic division. 2 add negative 5, you get negative 3 times 1 is negative 3 plus negative 23 is negative 26 times 1 is negative 26 plus negative 10 is negative 36, and this is not a 0. So therefore the factor theorem says that x minus 1 is not a factor. Okay, so we guess and check again. We're trying to factor this 2x squared polynomial thing. I don't know, maybe x minus 2 is a factor. Is it? We do the synthetic division, bring down the 2, multiply by 2, you get 4, plus negative 5 is negative 1, times 2 is negative 2, plus negative 23 is negative 25, times 2 is negative 50, plus negative 10 is negative 60. No, x minus 2 is not a factor. Okay, let's keep on guessing and checking. Let's guess and check negative 2. So bring down the 2, times negative 2 is negative 4, plus negative 5 is negative 9, times negative 2 is 18, plus negative 23 is negative 5, times negative 2 is 10, plus negative 10 is 0. Yay! I got lucky, and now I know that x plus 2 is a factor because the remainder is 0. So what we can do is we can say from here we go down to here, and I found a factor. The factor is x plus 2 because the divisor here was minus 2. So therefore, and then I translate this 2, negative 9, and negative 5 into 2x squared minus 9x minus 5. That's what that means. So this, if I were to distribute this or to multiply, using the box method, for example, then I would get back to this. But I'm that much closer to solving it because I have it factored. And now I can use all of chapter 3 to split the middle or use quadratic formula to figure out how to factor this second part. You notice the x plus 2 gets rewritten. It's the same down here, but instead of 2x squared minus 9x minus 5, I split the middle, and I eventually got x minus 5 times 2x plus 1. And now I can solve it way easier. The solutions here are going to be negative 2, positive 5, and negative 1/2 to this giant polynomial equation. That's what solving it might look like by hand. Now, before they had computers, it looked like this. Check this out. I'm not going to make you write all of this out because it's just a lot of writing to go on. But if you had something like this, and it was your job at some desk clerk to solve a polynomial, what you'd have to do, and there were reasons why they would have to solve equations. If you wanted to factor this, if you wanted to solve it by factoring, then you had to do a lot of guessing and checking. And maybe you guessed, 1, boom. And then you do the synthetic division and eventually get 0. Great. And let's guess and check 1 again. And then the synthetic division comes out, you get a remainder of 0. Good. And maybe you didn't, maybe if the remainder was 0, you just have to erase all your work and start again and guess and check another thing. And then eventually you get down and you keep on going, you keep on doing the synthetic division until eventually you got this. So collecting all of these numbers on the outside, 1, 1, negative 1, negative 2, 3, that's 1, 2 times 1, 1, negative 1, negative 2, and negative, and this right here should be negative 3. Because positive 3 could go in here. So that's literally how they would factor. This is ways to do with computers and with graphing. So we're not actually going to ask you, like nowhere on alex.com is it going to ask you to do something like this. I just wanted to show you what it might look like. In other textbooks, previous Algebra 2 textbooks, they would ask you to do something like this, and that was a lot of work. A lot of guessing and checking, so it was a little frustrating. But it's just not fun. I don't want to do it, so we're not going to. I want to remind you what the 0 of a function is. It's an output that produces 0. It's an input value. Let me start again. The 0 of a function is an input value that produces 0 as an output. So I'm giving a new term here, the multiplicity of zeros. And I'm not going to define it. I'm just going to show you what it looks like first. So I'm going to have... let's say we had this really huge polynomial. We've got 3 different factors with different exponents here. The zeros of this function, that is the numbers, the input values that produce 0 as an output. if the 0 is, for the 0 x equals 1, we know 1 is a 0 because when you put 1 in here, it becomes 1 minus 1, that's 0. And then it doesn't matter what all the rest of it is. When you multiply it all out, you get 0. 2 is a 0 here. 3 is a 0 here. And if you put 3 in, that's 3 minus 3 is 0. And multiply all the rest of it by 0, you still get 0. The multiplicity of these zeros, I want to be absolutely clear, the multiplicity of a 0, like sometimes people get confused. They think that a function has a multiplicity, like, oh, what's the multiplicity of f? Is it 5 or is it 6 or is it 9? No, functions don't have multiplicities. These zeros have multiplicities. So there are 3 different zeros, and I'm going to list them here, red, blue, black. And in this function, I'm going to say that the 0 of 1 has a multiplicity of 5. The 0 of 2 has a multiplicity of 6. The multiplicity of, the 0 of 3 has a multiplicity of 9. I'm going to say here, the 0 of 1 in this new version of this similar polynomial equation, the 0 of 1 has a multiplicity of 2. The 0 of 2 has a multiplicity of 2. And the 0 of 3 also has a multiplicity that you can find in the exponent of this particular factor right here. Now, you might say, oh, wait a minute, the exponents, so the exponents go 5, 6, 9. 5, 6, 9. There's no exponents down here, but it's unwritten. It could say the unwritten exponent is 1, the unwritten exponent is 1, and the written exponent is 3. So you go 1, 1, 3. So the multiplicity of a 0, we're just going to say that it is the exponent on that 0's factor when you've written it here in factored form. So the way we're going to use that on alex.com, they might ask you, find a polynomial f of x of degree 4 that has the following zeros. The 4 is a 0, 0 is a 0, and negative 8 is a 0, and that 4 has a multiplicity of 2. Leave your answer in factored form. Oh, thanks, Alex. All right, so what I'm going to do is I'm going to write x minus the 0. Everyone say it with me. Repeat this. Is going to be something we need to remember. X minus the 0. X minus the 0. X minus the 0. Say it. Yeah. Okay, so x minus the 0 is x. The first 0 is 4, and it has a multiplicity of 2. That's just saying that its exponent here is going to be 2. X minus the 0. The next 0 is 0, and x minus the 0. So it would be x minus negative 8, and the minus and negative cancel. You get positive 8, x plus 8. Now, if alex.com wanted to be really mean to you, it would ask you to multiply all this out, but it actually doesn't. It says you can leave your answer in factored form, no multiplication required. So you can just leave it like that, and that's the answer. Whew. All right. Well, that's that. I wanted to let everyone know that my favorite New Jersey beach is Brigantine. Don't really have any great reason why. I'm not saying it's better than your beach, but my beach is my favorite beach, and it's Brigantine, New Jersey. Where do you go to the beach? Which beach do you go to? Let me know, and I'll see you in class. Take care.